Hello everyone, my name is Fabian Castaño and I am the head of the project Characterization and Adjustment Model of the Cricopharyngeal muscle potential from surface electromyography signals in the swallowing process. This project was developed for my Alejandra Zapata, Valeria Cadavid, and Fabian Castaño from the University of Antioquia. As you know, the Parkinson's disease is a neurodegenerative disease that affects near to 9.1 to 13.8 per 100,000 inhabitants per year. It's a degenerative disease that affects the pharyngeal muscles and produce dysfunction in the swallowing process. This dysfunction is related with the loss of neural connection, also the alteration in the neural signal transmission, but also affect the cricopharyngeal muscles with motor disorder evidenced by the permanent contraction of this muscle structure during the swallowing. This distortion, this desynchronization causes intraesophageal stasis that anatomically coincides with the intervertebral space C5 and C6. One of the most important methodologies to solve this is the electromyography evaluation of the electromyography treatment, in which by the measurement of electrical signals or electrical manifestation of the neuromuscular activity, we can to provide some information about the function of the contractions of the real activity of the muscles. This technique has two leads. One of them is surface electromyography, and the other one is internal electromyography. In the case of internal electromyography or invasive electromyography, the process is very painful because need to insert needles like electrodes. Most of the time involves a medical supervision because involves a surgical intervention and provide high hospital costs and tedious recovery process. But other alternative is the superficial electromyography, where the electrodes are placed non-invasively over the skin, but the registered information from the muscle region are not from a specific muscle. That's why the superficial electromyography leads some problems in the treatment because the lack of the specificity. But in this work, we propose to develop a system based on an adjusted model from non-invasively obtain the potential generated by the cricopharyngeal muscle in the measurement of the potential on the surface to the neck during the swallowing process. For this, we provide a characterization of the signals by amplitude, fundamental frequency, and electric properties of the tissue to provide an electric and physical model where we can to decide how much we need to stimulate the muscle to recover the functions. And to provide this, we measure the potentials and develop a model for study the function of the muscle in the surface of the neck. For this, we develop some analogical and electronics conditioning that involves the electrical surface contact with the neck, with the muscles of the neck, also pre-amplification, a filtering to eliminate some noise, provide for the external sources, also other amplification to provide better information from the muscle, conditioning to eliminate some information that is provided for the body itself, but that is not from the process that we are studying. For this, we use some low-cost tools like Arduino, use frequency samples of 1 kilohertz because it's enough to acquire the information that is below to 100 hertz in the muscle that we are studying, and provide a signal processing technique that clean the signal that we are measuring. After the acquisition that we developed with a group of patients or volunteers that provide this study, we after that make the characterization in frequency and amplitude of the signal through signal processing techniques like Wells periodogram and the study of fundamental frequencies and the harmonics through the power spectral density study. Also, we evaluate the amplitude evolved by the Hilbert transform function, and process some of the noise when the moving average act to the signal. After that, in other side, we develop a 3D model of the neck based on anatomical structures, where we study and provide a physical model based on the electromagnetic theory of Maxwell, and evaluate how was the propagation of the signals through the body in a real conditions. Then this is a model developed for us, and we evaluate some physics equations that provide us real information about the functions of the process. Then we use the Laplace equation and the bioelectric source or the cable equation to do this study. After the characterization, we obtain a range of frequency between 5 hertz and 125 hertz, where is the most important frequency band of energy in the signal that we are studying. Also, we look how was the evolve of the different events when the people made a swallow in the process. With this information, we determine the amplitude of the signal, the impact of the event, but also we provide a real model of the propagation of this signal through the neck. With this information, we can to figure out how much energy we need to provide for electrodes that are disposed on the surface to interact with the muscle that we need to stimulate to produce the recovery or the treatment in the swallowing process. Then with this, we describe the better location to place the electrodes to detect the potential, but also to make the stimulation of the cricopharyngeal muscle. And also we figure out that the potential decrease from the source to the surface. That's why we need to provide voltage that equivalency can to produce some stimulation in the internal muscle. And yes, it is a good result. But also the results obtained in these simulations depend on the electrical properties of the tissue. That's why we need to develop some more specific studies where it involves more patients. But we can to introduce more specific properties of the conductivity of the tissues and how was the variation of these properties with the frequency. For example, how is the variation with the muscles, the fatty tissue, the vertebral body, e.g. Also, the non-uniformity behavior of the flow lines means that the bioimpedance can to provide some distortion in the signal that we are measuring. But with this model, we can to predict how will the signal that we provide to stimulate this muscle can to be sent to the muscle to do the stimulation. Also, we obtain some important measurement about the potential that we need to provide. Also, due to the analog conditioning, we can to measure with sure that the information that we obtain provide from the physiological process that we are interested and not from external noise in the process. As a conclusion of this study and this development, we provide a simulation of the muscle of a bioelectrical source using the cable equation, allow us to know the distribution of the potential generated in the volume conductor, depending on the electrical properties of the tissues. A specific behavior was presented by the potential drop in the different tissues. Likewise, the model fulfilled the expectation of the study, since it allowed to obtain potential to the cricopharyngeal muscle comparable to the touch potential in the process of invasive electromyography. Although the model proposed in this research was designed for the study of the cricopharyngeal muscle during the swallowing process, it can be implemented in other sections of the body to develop new tools to help the diagnosis or therapy of different pathologies. And as a future works, it is proposed to develop the model that establishes the new support strategies for the recovery of the motor alternatives in the people with Parkinson's disease, such as the study of the electrical stimulation in therapeutic process. Thank you so much. Again, my name is Fabian Castaño, and I am behalf of the team of development of this project. I am part of the University of Antioquia from the Physics Institute. And here we are the contact of the members of the team where you can to contact us. Thank you so much. And I am glad to present this kind of development from Colombia.